Exactly. Have our next speaker already lined up. Ahmad-Reza Sadeghi is a professor of computer science and head of the System Security Lab at Technical University Darmstadt. He has been leading several collaborative research labs with Intel and Huawei. He has studied both mechanical engineering and electrical engineering. He also a PhD in computer science. And prior to academia, he worked in R&D departments of IT enterprises, for example, Ericsson Telecommunications. So I'm really excited to have you here and talk about collaborative self-learning for security, fun, and profit.
Okay, thank you very much for the introduction. I think 12 o'clock is the very critical time to give a talk. People are very impatient. They start to get hungry, passive-aggressive, and maybe also ask no questions and go to sleep. But this is a very short talk. And it is about actually my own journey through the collaborative learning, specifically transferring scientific results into real-world applications in collaboration with many big US companies, unfortunately, because German companies, no offense, they are not very open. And it was really fun because you see how impactful research can be in practice. And that is the fun part. And then when you have the insights, you get a lot of requests for consulting. You found startups with very smart students. And that's the profit part. So let me start with the motivation. So as the hype of machine learning and AI as the general concept started in US and 10 years later came to Europe and specifically in Germany, everybody was asking what is actually the use of machine learning as a core technology. And as my focus is cybersecurity, I was asking myself, what is actually the use of machine learning for me, for my group, because I have a relatively large group, and what we do in future, because most students came with applications from all over the world to me and saying, I want to do a PhD in machine learning. And I said, why? I said, we don't know, because machine learning is hype, it is very fun. And this is why I started some years ago to build a group on machine learning. And the questions and challenges that raised at that time were as follows. So the first question is, can machine learning improve security in a meaningful and sustainable way? Sustainability is very important here in terms of security. Can you give a guarantee for security? And meaningful is even more important. If machine learning and AI is the solution to all the problems in the world hunger, nature problems, climate change, from security point of view, for large-scale systems, you need automation. Automation is not always good because things can be done stealthily. You need scalability, but accuracy is very important. A system which is secure with 90% of chance is not a secure system. So, and if you use the so-called intelligent systems, how do you really explain the security there? This is a big question that is being subject of research. The next question is, can ML, machine learning, I just use ML, utilize data sets without sharing them? This is a very old problem, actually the holy grail of cryptography, of modern cryptography. How can you compute on data without seeing the data? So how can you compute on encrypted data? And the question was, is it possible that machine learning here helps in a certain way or to some extent? The last question, and the most important question is, can existing security mechanisms, features, and methodologies protect machine learning against various adversaries that I'm going to talk about a bit here? This is very important because all machine learning algorithms are fragile to all kinds of attacks. And it is really fun to sit with smart students the whole week and hack into any machine learning system that is proposed in scientific conferences. And this is, of course, adversarial machine learning is a big and hot topic for itself. So these are the three main questions. And I would like to go through some of them. So to touch upon the first questions, at least touch upon, not solve it, completely solve it. We looked into the collaborative distributed learning, and I think this is something that's very important for industrial usage. So I think that most of you know what is collaborative learning, or just can imagine. And in this talk, I'm focusing on federated learning, and federated learning should have been known to many of you because you're all here for machine learning, data sciences, and AI in general. But some basics. So in a federated learning system, there are a number of clients. It could be 2, it could be thousands, it could be millions. They have their own data. They do not share their data among each other. They do not share this data with a central server. This is the next party, which we call aggregator. What is happening is that each client trains a model on their, so to say, own private data. And then when the model is, so to say, trained, after a certain phase, after a certain time, it uploads it to the server. The server magically aggregates these models together and decides this is the resulting model and downloads it to the clients. So the idea is you don't share the data, you just share the model updates. And then you also get smarter after each, so to say, frequently, this procedure can be continued frequently depending on system parameters. Okay, so this is the basic of that. Now, what are the promised benefits of collaborative learning, or in this case, federated learning? Improved privacy, because you do not share the original data, but it is improving the privacy. It is not absolute privacy. The second thing is hardware efficiency. You are dividing the computation among many, many clients. And the third is performance boosting. Theoretically, you are boosting the performance of utilization function, because you're using the knowledge of many parties. Now, there are many, many applications of federated learning. Some general applications are autonomous driving. In this conference, this has been presented many times. To use that for example, improving object recognition, because you get data from each of these vehicles, which are the clients here. Medical assistance, collaboratively learn brain tumor segmentation, which is a big project that my group is involved with Intel. And word suggestion. So training word, your keyboard, this is a big project at Google. Now, as I said, I am doing cybersecurity, and for us, it was important to know, is federated learning useful in security applications? And we started with a project with Cisco. I think most of you know Cisco. It's a networking company. And the question was, at that time, there was another hype, and it is still a hype. It was called IoT, Internet of Things. So when you have thousands of devices and many different manufacturers and vendors, how do you handle the fact that when the connectivity among these devices is very high, and some of these devices are, so to say, infected, they could infect other devices because they have high connectivity. And this was shown in 2016 and 2017 through the Mirai attacks, where more than, I don't know, up to 400,000 devices were connected to each other through a malware and could attack the backbone networks of big data provider or service provider like Netflix. Imagine what happens in US if Netflix is down. Half of the people go crazy, and they are also having guns. So this is even worse. So, I mean, this is a big problem, and to solve this problem, the question was, can we use federated learning for intrusion detection in a large-scale IoT network against denial of service attacks? And the answer was yes, because the conventional systems that we know from industry or from academic research, they were not scalable and they were not applicable to IoT scenario because of diversity of devices, because of different protocols, communication protocols, and also scarce communication between devices. Now, the second application that I'm going to dive in a bit is on sharing cyber risk intelligence. This is a problem that I think has immense applications and was kind of stopped due to reasons that I'm going to explain. So let us go a bit into the improving risk detection and management. So the use case that I'm going to talk about is on cyber, so mobile cyber risk intelligence for mobile applications. And the reason why I would like to talk about mobile application is that they are fast growing. They are, so to say, specifically in the pandemic time, they got even bigger, the usage of mobile services. And then we had the problem that through this, the attack surface also largened. What does it mean? It means that the threat that is now we are facing is getting bigger and bigger because you're using more digital services. Now, how do we deal with this? There are, of course, ways to estimate or predict threats and risks, both for customers and mobile service provider. And this state-of-the-art is called cyber threat intelligence systems. What does it mean? It means that you share information about the so-called indicators of compromise. That means companies come to each other and say, hey, this is my incident response report, these are my IP addresses, these are my log files, I have been attacked so many times, and we share this information with others, we put them together and see if we can provide the right defense for it. So this is nice, and it has been done. The problem is that there are a number of challenges that we always face. And I want to generalize this problem. First is, it is difficult to manage because there are lots of information, lots of standards, lots of data formats. Bringing them together is very difficult. Then there is an interoperability automation problem. There is no automation, so there are lots of manual work. And the most important aspect and challenge is the privacy aspect, reputation aspects. Companies would not provide the attacks to their systems, the problems, the log files to each other because they have business issues with that. So how do we solve this problem? So we had a lot of requests from a number of companies. We decided to sit with them over a very painful talk to lawyers, and that's what I always want to avoid, please, no offense, because I like the technical things and not talking about some paragraphs and some NDAs. But indeed, after 1 year talking, we started to work. And what happened, and that is, I would like to explain to you a bit what is a risk analysis framework in a mobile application. So very, very high level, you have a service provider provides you with an app. This app has the kind of mobile service in it that you are using as a customer. And the app also integrates a risk management component. Many of you may not know it, specifically in financial services. And what it does, it just estimates, predicts certain unusual activities on your phone and reports it to the service provider or warns the user. And this is done, of course, with some sophisticated algorithms that are hidden to you, but it is still at the application level because application providers do not have access to operating systems. Only operating system vendors have access to it. So there are various risk categories. For example, at OS level risk category is something like, is your phone rooted? Some people take the phone, iPhone, and root it, jailbreak it. That means they install their own system on it. Is your phone, for example, so to say, is there any application on your phone that has certain permissions that can attack your application? This is, for example, a risk on application level. And there is another risk which is cooler because you may run the application in a virtual environment. So the application checks, do I have access to certain sensors on my phone to probe if it is running on a real hardware? And it's not that the adversary puts your application in an emulated environment to analyze it, to attack it. So that goes too far, but just some aspects of application security. So what we did with all these companies, we started to do a risk analysis modeling of these kind of risks that I mentioned to you. And then provide a platform for federated learning so that you can have a cyber intelligence sharing platform without really providing these, so to say, these data to your opponents. And that, at least, and certainly the evaluation of the whole system in a very large-scale manner. What does it mean? It means that we started to, here you see an example. You see, for example, a payment provider and an online banking provider. Each of them has its own cyber risk model, which is fixed from the beginning. And then what is actually a risk, what is not a risk, what is the degree of risk, what is the degree of the threat. And then they, on this local data set, they train their models. And then the cyber risk intelligence sharing, if you remember, this is the server, the aggregator part. And then there is a communication here. The server puts the locals model together, aggregates them. It downloads them then after a while. This is called the federated risk model. And then the federated risk model, after it is finished in the procedure that I explained, the interesting thing is that you can give this model to any other party, and the party can start with it, working with it right away, okay? This is theory, beautiful pictures, but is it going to work in practice? Because we have heard about data scientists, lack of data scientists, problems with data scientists. Yes, these are all the problems that the engineering part kicks in, because scientific part is gone after the algorithm is on the paper. But the engineering part, cleaning the data, checking what features are important, taking care of what a model degradation, because once you do an update of operating system update, a risk that was a risk before may not be a risk afterwards. How do you avoid the human expertise, so engagement of human expertise? These are the problems that we have. Okay. And the data set overview was that we have a real world. We have 9 companies all over Europe. They provide different services in different sectors. And we had around 24 million users. And we applied this system to it. And that was the fun part. You see that it is working. I was very skeptical about the solution to all the world's problems. That means machine learning. And that is a kind of, I don't name the companies, but this is the distribution of different operating systems based on the company. So company A has, for example, customers that use Android. There are 140,000 of them use Android, and the rest use something. So the last part of the talk, I would like to come to the topic that takes, so to say, very short, on attacks on federated learning. So this was, so to say, that the romantic part is gone. Now we are coming to a real part. The real part is, how do you hack into these systems? So what are the problems of these systems? So the first is, what happens if the client is compromised by means of malware? What happens if the data and the model is poisoned? This is what we call it so to say, as a terminology. Now, what does it mean? If a client is compromised, then the model is poisoned, and what happens is that when the aggregator distributes the aggregated model to other clients, all other clients have also poisoned model. What does it mean, poison? You manipulate the data. And what does it mean, poisoning? It means that either the adversary wants to destroy the outcome of the algorithm, the aggregator, that the predictions are wrong, your beautiful cat is categorized as a squirrel, or your car is categorized as a helicopter. But on the other hand, this is the controlling. And the other one is the adversary wants to change the outcome of the algorithm according to their own data. So if the vote is for Trump, it should not be for Biden, or the other way around. So who knows in the US? So now in aggregator part, we have another problem, and that's the problem of data leakage. What happens if I give you the weights and the neurons or whatever of my algorithm, and you can extract information about the original data? And this has been shown that it is possible. In some cases, it is not useful. And in some cases, even 1 bit of information is useful. For example, your gender or for example, for whom you voted. That's it. The federated learning has a large body of literature as it was introduced in 2017. I think I'm over time. As it was introduced in 2017, until now, more than 6,000 articles have cited this paper. This paper was originally proposed by Google, and more than 2,000 articles are only on security and privacy of federated learning. So the last slide just shows you after introduction of vanilla algorithm, there were the first attacks. Then these are some examples. And then there were defenses. The defenses had the problem that they could not handle sophisticated adversaries because sophisticated adversaries know how the defense is built. And then we started to kick in. This is only pure academic research where we provided some, so to say, defenses that address these shortcomings of the literature. And if you are interested, you can talk to me about the details. I'm not going to. So in conclusion, yes, federated learning can be used for improving security applications. However, we cannot transfer the current security means and technologies and methodologies directly applied to machine learning and to AI in general. We need new technologies. So this is what we call security by design is very vital here. Our research has even elevated the state of the art, but there are a number of open questions regarding security of all these algorithms. Thank you very much for your patience.